Okay, let's look at this question here, which is taken from one of the school tutorial, ACJC, I believe. So this is taken from the year 2001 H2 math paper 2, question 14. Okay, so a rectangular tank has a horizontal base. Water is flowing into the tank at a constant rate and flows out of a rate which is proportional to the depth of the water in the tank. Okay, which makes sense, right? Because if you think about it, the deeper the depth, right, then the faster you leak up, meaning it's like higher pressure, lower pressure. So that's the whole idea, right? So at a time t seconds of the depth of the in tank x, right, x meters, if the depth is 0.5 meter, so they told us that the depth is given by x meters. If x is 0.5, it remain at a constant value, meaning to say, okay, dx dt is not changing. Constant value just means that it's not changing. Okay, the rate of change is 0. Okay, show that dx dt is equals to negative k2x minus. So I think it's pretty okay. So let's I'm just going to draw out the tank first. So this is a rectangular tank. This is x, right? This is x, the depth. Okay, so the water was given that is flowing in at a constant rate. So I'm going to write dv dt in equals to k. Okay, constant rate k. Or maybe don't let it be k, let it be like, let's say p or something. Okay, it's like a constant rate there. Then after that, it flows out at the rate which is proportional to the depth of the water. So meaning to say, this guy here, we have dv dt out. Okay, proportional to x. Okay, that's the two things I could write it down. So this is what we can write, dv dt in and dv dt out. Okay, where p and k are positive constants. So if you write this down, dv dt net will be in minus out, so p minus kx. Okay, now the thing is, you realize that x, you are told to find dx, not dv dt, although you're told that this is like the water flowing in should be volume per second, right? So but understand that at any given juncture, the volume of water is equals to base area. Let A be the base area, right? So V is equals to AX. Because the area is held constant, so I don't care what is the area. I know that V, at any given juncture, the volume of water is always base area times height. So we can conclude that the volume of water at any given juncture is A times X, right? So in this case, if I were to, okay, you could replace AX into this guy, or you can just use implicit differentiation. It doesn't matter. What we can do is, so combining 1 and 2, this will give us d dt AX. Now, because A is a constant, so we can just bring it up. So A dx dt equals to P minus Kx. Okay, so dx dt will just be given by P over A minus K over AX. Maybe I shouldn't have used K here because there's a K here. So there are too many Ks around. I'm going to let this be Q then. Q. There you go. So I get this P over A minus Q over A. Then after which we understand that we're told that when x is 0.5, there's no change in the depth of the water. Can we just substitute this boundary value here? So 0.5 is obviously half. So I just leave it as half here. So we can get this out. Then this will be Q over A 2 equals to P over A. So Q equals to 2P. Okay. So then from here, what we can do is just substitute this Q over 2P inside here. Then we just try and see what we'll get and how can we simplify this expression. Okay, from here, you can see that x is positive here, 2x. So I'm going to factorize the minus 2p out. Sorry, minus p over a out. Then this will be 2x minus 1. Get dt. Okay, so let k equals to p over a, where k is a positive constant because p and a are both positive. Great, then this will be dx dt equals to minus k 2x minus 1. Shown. Got it. So then we are told to solve, because when t0, you have x equals to 0.75. So this case here is just asking you to solve the x. Oh, and also it's decreasing at this rate. Okay. So I'm gonna just write when x is 0, when t0, x is 0.75. Then decreasing at this rate, dx dt is given by minus 0.75. Okay, so this case we could replace 0.01 with the decreasing at 0.01. Okay, so this case we could use essentially could just substitute this boundary here into this guy. So I'm going to replace it in. So this will tell us that dx dt is 0.01 equals to minus k 2 multiplied by 0.75 minus 1. Okay, so I just replace this the rate in and the x in. Okay, that's it. K will be a positive constant of 0.02. Okay, great. So once this is done, we know K is 0.02, which is actually 1 over 50. Yeah. Okay, so we know dxdt is given by minus 1 over 50, 2x minus 1. Then we can solve this. This is separable form, so not an issue. This is 2x minus 1 dxdt equals to minus 1 over 50. Okay, then you could just take this and move it to the other side. Then you just enclose it with what do you call it, the integral. So this is 2x minus 1 dx separable form. If your school don't allow you to write this case here, don't worry, you just put the integral here. Okay, just put it here, it's fine. So this will be ln 2x minus 1 over 2 equals to minus 1 over 50t plus c. Okay, that's about it. So solving this shouldn't be an issue. Make x a subject. So expanding the exponent there, then you get this case here. Then what we get is plus minus e2c e minus 1 over 25t plus 1. I'm going to let a be this guy here. This entire thing is a constant. Yeah, I think I should just let, because it's half, right? I just let a equals to, this is 2 divided by 2. Okay, looks nicer. So we can replace the boundary condition in t0. We told that x is 0.75. So this guy will be 0.75. So a is 1/4. Okay, so there you go. X is equals to 1/4 e minus 1 over 25t plus half. So the last part will be we just replace the value in. So when x is 0.55, what's the timer? So 0.55, and x is 0.55. This will be 0.55 equals to 1/4 e minus 125t. Be 1 over 5. Just rearrange along both sides. I get t equals to minus 25 ln 1 over 5, or rather 25 ln 5 seconds. Since everything is in seconds, okay? If you don't like to write in exact, you can also leave in 3SF, which is 40.2 seconds. Okay, that's all. Okay, so that's how we do this question here proficiently. And then if you have any questions, please do let us know. I'll see you in the next question.